Alright, now we're going to talk about graphing our exponential functions. If you remember way back to the beginning of the school year when we did parent functions, we talked about these lovely little things called A, H, and K. So let's see if we remember what A, H, and K stand for and how they affect the graph or how they change the graph. So I'm thinking, I remember H. H is the easiest one. H was horizontal shift. And the reason I remember it is because horizontal starts with the letter H. Now horizontal goes to the left and to the right. So to the left, I got to look for a particular sign. Which sign moves me to the left? Yep, it's going to be opposite. The positive sign moves me to the left and negative sign moves me to the right. It's exactly backwards from what we think it would be. Okay, so then now let's look at K, because K is another easy one. If H is the horizontal shift, that would make K the vertical shift. Okay, good job. So that's a vertical shift. Vertical is up and down. Now notice the K has a plus sign, so it's intact. We don't have to flip it. So plus is up, negative is down. It makes perfect sense. It's okay. Now let's think about A. A has two parts. Remember the sign of A, plus or minus, tells me if it reflects. So that's if it flips upside down. And then I got to look at whether it stretches or compresses. We're actually not going to deal much with that because the number is going to change the type of graph that we have. So now let's look at the first one, number 1. I see what? I have a negative sign and I have a 6. So I got a negative and I have that 6 right there. So the negative tells me it reflects. So I'm going to put down that it reflects. And then what's the 6 doing? Is it the H? Is it inside with the X? Or is it outside at the end? The answer is it's inside, so it's going to move 6 in which direction? Left. Okay? So now I have to kind of go back and remember, what in the world does exponential function look like? So I'm going to do three to the x power, okay? Because I have a 3 here, so 3 to the x. And I'm going to look at my graph. Now look at my graph. Oh, there he goes. Now I want to get some specific points here, so I'm going to go to my table, and I see in my table, oh look, it goes through 0, 1, so I'm going to put a dot at 0, 1, and then I notice it goes through 1, 3, okay, I can handle that, and the next one's 2, 9, and 2, 9 is off my graph, so I'm just going to put a little dot right up there, okay. Now, I notice it gets really small really fast. Look at how small those numbers are. So it's going to get really, really close to 0. So I'm just going to put a little dot right down here to indicate to myself that it's going to get really close to 0. Now, that's for 3 to the x. Okay? So I'm going to draw this in. Okay, this is 3 to the x. But that's not what I had. Okay? I had what? I had a negative 3. So I got to change this. Negative 3. To the what? Parenthesis x plus 6. Okay, now we already said it's going to move 6 to the left. Okay, so I'm going to come over here, I'm going to move 6 to the left, and I'm going to put my dot. Alright, now we said it's going to flip upside down, so let's see. As it flip, oh look, there it goes. It's right there. Okay, so it flips right upside down. So we're going to come in. And you can see at negative 6, it's at negative 1. Oops. So it's right down here. It's at negative 1. And then it kind of goes backwards. So we're going to go over here, and then we go down to 9. So do the exact same thing, flipped over the x-axis. So this curve is the correct curve. This has the description and the shift. Okay, so we flipped it upside down. Alright, now let's look at the domain and the range. Remember, domain is x's. Okay, so x values only. If I go to the left, does it keep going? The answer is yes. So I know it goes to negative infinity. Okay? Now, does it keep going to the right? Kind of. It kind of goes into this asymptotic behavior right in here. Does it ever actually reach the negative 3? Not really. Okay? Now, we originally said that it was all real numbers because it might, it might actually get there. Okay? So now we have negative infinity to positive infinity. It's going to keep going to the left, keep going to the right. Okay? Well, let's look at the range. If I look at the range, range is what? Range is my y values. So these are my x's, these are my y's. Okay? So, range, does it keep going down? How low does it go? Well, it goes all the way to negative infinity and beyond. So, we're going to keep going there. How high does it go? Well, it goes all the way up, but it never hits the axis. Okay, so it's going to stop at 0. Okay, so it only has the negative half. So that would be my range. Now let's look at number 2. Let's describe what's going on with number 2. Well, is it reflected? No, not reflected. That's good. Now I notice I have this x negative 3. Okay? So the negative 3 tells me I'm doing what? 3 to the right. Okay? And then I'm going to do what? I'm going to go up 1. So from 0, 1, that's my magic point. From 0, 1, I'm going to go 3 to the right. 1, 2, 3. And then go up 1. So I always start at 0, 1. But my new curve is going to start right here. It's going to start at 3, 2, because I moved 3 to the right and up 1. So my original curve, which I would have drawn looking like this, okay, is now going to be drawn over here. So we're going to go down, okay, and then it will go up. Just like that, because it's not flipped, it's not reflected. Now notice what happens. Let's look at my domain and my range. Okay? So my domain is my x's. Does it keep going to the left? Yes, it goes all the way to negative infinity. Does it keep going to the right? Yes, it does. It goes to positive infinity. So we're going all the way negative infinity, positive infinity. Now the range, the y values. How low does this go? Well, the original one went all the way to 0, but the new one won't go any lower than 1. It's not going to go any lower than the 1. Okay? And then, how high does it go? Well, it goes all the way to positive infinity. So we're going to go from 1 to positive infinity. And this concludes our graphing section of exponents.